Hello students, today we're looking at solving systems of equations by graphing. Feel free at any point in time to pause the video to see the screen or have a better understanding of what it is I'm writing if I'm going too fast. Alright, so first off, what is a system of equations? So that is where we have two or more equations. Okay. All right, and the answer to a system of what does the answer to a system of equations represent? It represents an ordered pair intersection point. So when we graph these, they create an ordered pair intersection point, and their overlap is our solution. And when you plug that in, it satisfies both equations. I'm abbreviating equations there to save some time. So, all right, so when we plug it in, we get the solution for either equation. Now, there's three different ways to solve systems of equations that we'll look at. The first one we're looking at today is graphing. Then after graphing, you have substitution, which we will not be doing today. And then the third way we will also not be doing today is elimination. All right, but for today we're looking at the graphing version of this. All right, so possible solutions. We've got three things that can kind of happen with the graph. So the description of the graph, if we have an intersecting point, okay, if the graphs intersect, that is when we will have one solution. Okay, if we get parallel lines is when we get no solution. The reason is no solution is because the lines do not intersect. And then the third option is that we have the same graph. So it's like one line graphed on top of the other, and that's when we get infinitely many solutions, or we abbreviate it with IMS. So infinitely many solutions for that. All right, so there is that. Let's go ahead and move on to an example here. So for number one, basically what we're going to do is we're going to graph both of these and just see what happens, and then take a look back at what that description that goes with it. So for the first one, our y-intercept is at -1, and our slope is 2. So we go up 2 over 1, up 2 over 1. We don't know where it's going to cross, so we're going to put all these points on here using a ruler. Can help you go a little bit faster. And to make a perfectly straight line, there we go. So there's our first line. The second line we're going to graph and just see where does it intersect, or if it doesn't intersect. So this one has a y-intercept at +5. So we go up to 5, put our y-intercept, and our slope is down 1 over 1. So there we go. Once we have the intersection point, we don't need to put more points on there. All right, and this intersection point is then going to be our solution. So that's at the point, here's the origin, so we go 2, 3. So 2, 3 will be our answer. Now, we see that that is the intersection point, but also if we were to take these two, this x and this y, and plug it into either of these, we would get a true statement. So like if I take 3 and sub that in for the first one, so if I do 3 is equal to 2 times x, which is 2, minus 1, I would get 4. 2 times 2 is 4, 4 minus 1 is 3, so that works. And then I should also work when we plug it into the other one. So 3 in for y for this one, that would be a negative, plug in 2 plus 5. So is -2 plus 5 is also equal to 3, so there you go. It works when you plug into either equation there. All right, so pause that if you need. I'm going to go ahead and go to example number 2. All right, for this one, we can go ahead and graph the first one. However, the second one is not solved for y. So we're going to have to solve for y before we graph it. So here we go. Let's move the x over. So subtract, that's like a 1x. So we subtract minus 1x. Bring down the -3y. Okay, so we have this. I like to write the x closer to the equal sign because that's similar to slope-intercept form. We're going to divide by -3. Everywhere we get y equals a positive, because of the negative, we get a positive 1/3 x plus 2. So I'm going to graph this one, and I'm going to graph this one up here, right? Because this is all really the same same 1, I just had to solve for y. So notice 1/3 x and 1/3 x, they have the same slope, but different y-intercepts. So let's go ahead and graph this one. We're at -3. We're going to go up 1/3, up 1/3, okay, down 1 and back 3 to put a couple points this way, graph the line. Now we want to see where they intersect, but since they have the same slope, they should not ever intersect. That's the definition of parallel lines. So we go up to 2, we're going up 1/3, 1/3 like this, down 1 and back 3. We don't have to keep going because we know they're not going to intersect since they have the same slope. And there we go. This means we get no solution because they don't cross. So that is number 2. Again, pause it right there if you need to fill anything in. All right, let's go to number 3. Again, we've got one that's not solved for y. We're going to graph this one for sure, but this one we need to divide by 2 everywhere to get y by itself. So we get 2x minus 1. So now if I look, I've got 2x minus 1 here and 2x minus 1 here. So this is our example where we have the exact same graph. Okay, and so when that happens, that means you've got one, the first one at -1. We're going up 2 and over 1, up 2 and over 1. Okay, and we get the same line when we graph this one. Apologies for the interruption here. I'm going to keep going. Hopefully this announcement won't take too long. So this one, we get infinitely many solutions. Okay? All right, and then this last one, we're going to solve for y, and I'm just going to put the solution on here. Y equals 3x minus 4. So apologies for the interruption there. All right, but this one's already solved for y. This one is not. And actually, just to go back, just to reiterate, this one you got the same thing for the equation. It's the same line, so it's like graphing one on top of the other, and you get infinitely many solutions, or IMS. All right, for this one, the first is already solved for y. The second one is not, so that's why we divided by 3. And so we've got 2 different things, so we should get an intersection point. So let's go ahead and see what we get. We're at -2 with a slope of down 1/4. Down 1/4 goes like this. Up 1 and back 4 would be the opposite. Right there. All right, so then we draw a line. Not the best straight line there, but good enough for what we need. And then for the second one, the y-intercept is down here at 4, and we're going up 3 over 1. Okay, we should see, once we've got our intersection point, we don't need to keep going with more. But now if we look really close right there, it's not on a nice round whole number. So we have to estimate that. So I'm going to say approximately, we're going to be at the point, it's between 0 and 1. So it's, I'm going to say about 0.7 is my estimate. And it goes down past 2, but just barely, so I'm going to put down 2.1. And that would be my estimated answer right there. Okay? Again, feel free to pause and go back to any part of this. Hope you guys have a great day, and please reach out if you have any questions. Thank you.